Hello, my name is Alan Folmsby, and today I'm giving a lecture on theoretical physics. This is the 17th lecture in a series that's happened recently, 3 days a week, and I'm going to review all 17 of those lectures there. If you've been watching, you know that it features the nuclear structure, and I'm going to be showing you very little of these mock-ups. You can get your own periodic table on my other website at the pyramidalcube.blogspot.com. So I could just summarize the entire semester as the theory of everything, but I'm not going to do that. This is called the theory of enough. All right, we don't have to cover antimatter or black holes. Other people have covered those things very well in the past. I'm focusing on things that we care about on Earth, such as gravity volume theory, nuclear structure, and I've also brought in some new force formulas for gravity and electricity. These are based on the radius of the proton. And another highlight of this was the mirror in the proton, which is connected to an electron. So what I'm going to be talking about in gravity volume theory is going to be shown in several of the lectures. And what I've done is I've prepared a bunch of text for you here to read while I give you more details on these things. Hello, it's Alan Folmsby here in my front yard. This is where I discovered the shape of the iron nucleus. All right, so I've now turned the camera around to give you more details about the theory of enough. I'm going to give the reverse order of the lectures for you here. So here I've typed them in, and this is the fall 2019 semester. There were 17 lectures, including this one. My name's Alan Folmsby. I have a Master's of Science degree in Electrical Engineering. And this theory of enough is about theoretical physics. So the lectures are listed here. And I started out last Friday talking about abundance of the 118 chemical elements. And then on the Wednesday before that were the pear-shaped evidence that experiments match up with my theory. And then the mass equals area theory is a basic thing in which I'm using abstract physics. Then there was ferromagnetic elements were described 2 days before that. And then another lecture was on the molecule from nuclei, a single molecule of a chemical taken from several nuclei. And this is a new kind of three-dimensional modeling I'm doing that I'll explain a little bit more on each of these subjects in a minute. And then there's the radon experiment, supports my nuclear pyramidal cube theory. Then the neon theory of some people in Europe also supports the shape of the nucleus of neon that I proposed independently. And these shapes are influenced by the flat cosmologies in an atom, that the pairing between electron and proton is kind of like a flat sub-universe. And then along those lines was the cosmology of eternity. And then ab initio, this is a Latin lesson in from the beginning. What are the basic principles? Like conservation of energy. I compared that to the new ideas of the conservation of continuum. That's momentum, basically. Momentum of free space. And another lecture I gave was on the periodic table 150 years after Dmitri Mendeleev had created it. And the new periodic table of nuclear structure is available on my website on the impuremath.wordpress.com. I did a lecture on technetium because that was a puzzle that lasted for a long time. People knew that it was missing from the periodic table, and now people found out it's because it's radioactive. But why is it radioactive? And I've answered that during that lecture. Then there was a few more lectures at the beginning of the semester. The strong nuclear force is gravity, which is controversial since gravity's 10 to the 40th times weaker than the strong nuclear force. And I'm saying that the derivatives of time are much more important up close to the nucleus. And then there's future electricity, future physics, and future science lectures back on when I started, November 4th, 2019. So here it is, December 16th. It's been 5 weeks, 3 days a week of lectures. Now, I'm going on the holiday for now. I'm not going to be giving lectures for a few weeks during the holiday, but there will be live streaming workshops I'm going to show in physics of the nucleus model assembly, starting with hydrogen and going up to beyond germanium. That'll be every Monday and Friday at 10 a.m. Hawaii time. So 2 days a week during the holiday period. And then I'm going to start a new semester in January of 2020. All right, so I've put together some additional comments from today on all 17 lectures. So just what I wanted to say is about the abundance of the elements, is that there's two ways that the abundance of the elements could have been produced, or both. It could be primordial creation of heavy elements, or were heavy elements created out of light elements. So in other words, a long time ago, 100 trillion years ago, there was possibly a huge neutron star containing all of the matter in the universe in one place, in one cube or one ball of 10 light years across. And then that expanded. It continued expanding through all eternity and expanded to the place we are today, and all the nuclei broke apart from each other from heavy elements in the beginning, and those broke apart into lighter ones, which is the primordial heavy elements theory, that they started out even heavier than technetium or uranium, but then they broke down into lighter ones, and that's in the crust of the Earth right now. But another path is start with light elements like hydrogen and have fusion inside the stars, as standard science says, and in fact both events could be occurring. Now, during the lecture on the abundance of elements, I did talk about the octet rule. See, in chemistry, they often use the 8 rule, the rule that 8 electrons are involved bonding 2 atoms together. So that's for light elements. But on the other hand, for the medium weight elements, the rule's 18. There's, as for example, there's 18 elements in the periodic table. 18 groups of columns. And then there's another rule, the 32 octet rule. And that was figured out, I think that was just Friday. And here's the notes from Friday I have. 8 is equal to 6 plus 2. 2 protons are in the cube in the center, and the cube has 6 faces. So that's 2 plus 6 is 8. That's where the octet rule comes from. The rule of 18 is 6 times 3, where 6 is the number of faces of a cube, and 3 is how many protons are on the tip of each pyramid that covers each face. And then the rule of 32 is the 18 that I just described on the 6 faces, plus 14 more protons in the cube at the center of the very heavy elements. All right, then I spoke about a lot of other things in detail, that the pear-shaped barium is really raindrop-shaped. It's falling. It's moving relative to something else, like a raindrop is moving relative to the air. So barium is raindrop-shaped because something is moving past it in relative velocity. And the shape there forms an armor functionality. Now, part of the research that I propose for future experiments as a theoretical physicist, I'm requesting that experimentalists at NASA or someplace else would do microgravity experiments on the simple cubic lattice formation. Oh, there, that's a little better. So the formation of the simple cubic lattice under zero gravity in orbit, say the International Space Station. They could bring up thousands of little spheres and press them together and see if a simple cubic lattice will form, or if it will be just randomly placed spheres, or maybe it'll make hexagonal close pack in there, or both. So it's an experiment I'm interested in, and it goes beyond the barium experiments at Argonne National Laboratory, and using radon and radium also. And those experiments were done using a radioactive element called californium. They'd take a beam of californium and collide it into lead foil, and barium would pop out as some nuclear reactions go on. And it was very neutron rich. Now, under the mass equals area theory, I was basing this algebra of that lecture on the electron mobility is being equal to conductance. And these are the only two duplicate units in the standard international system. The SI system, MKS, units of measure, meter, kilogram, second system. They have the electron mobility is square meters per volt second, and conductance is the inverse resistance. So I would like to tell you a little bit more about that in this slide right here. So in order to show several proofs that mass equals area of the liquid continuum, I've used geometry, I've used persuasion, I've offered bribes, but also I've used algebra. Algebra of standard science equations, but with a different understanding that the mobility really is the same unit of measure as conductance. And I'm comparing resistance to mobility, electron mobility. The resistance R, of course, you're familiar with, ohms. That's the 1 over G is the conductance. 1 over conductance is ohms. Resistance is just the inverse of G, and it's a unit of measure, measured in Siemens, inverse ohms. Mobility is secretly the same unit of measure as G. They won't admit it, but I'm trying to place payments to the correct scientists to get them to admit that mobility is secretly the same unit of measure as conductance. And in that lecture, I gave detailed explanation of why this is. It's partly an English language trick they use. Electron mobility equals conductance, not electron conductance, because the conductance equation has the electron charge in the formula. But then they use the electron mobility phrase, but in the formula they don't have the electron charge. So it's the same unit of measure exactly. The only difference is magnitude. For example, capacitance is a different unit of measure. 1 farad compared to 1 ohm. Clearly two different things. Inductance is a henry. It's not equal to an ohm. A henry is not even, or meters per second, unit of measure of velocity, is not an ohm. However, standard science refuses to recognize mobility is secretly the same unit of measure as conductance. Now, by going beyond that, I've shown that mass equals area in that lecture. Now, experiment versus theory. This is very important of what I was talking about during this entire semester, is that I'm proposing theoretical physics, but there are some experiments that back it up. Now, my theory of nuclear structure, for example, is a static nucleus theory of fossilized shapes from primordial events. Nuclear structure is a bunch of fossils, the survivors. The pyramidal cube nuclear structure is a survivor. And the experiments that were done about the pear-shaped survival type of shape, of the teardrop, raindrop-shaped barium, those experiments are like having a microscope with a 500 billion x magnification. But my theory has 100 times that resolution. 50 trillion x microscope-like silhouettes have been produced. So back to going to the ferromagnetic elements lecture, I talked about all 4 ferromagnetic elements: iron, cobalt, nickel, and gadolinium. And I picked on those because they have strong properties that are easy to measure as magnetic elements. And so I figured that their nuclear structure would have some kind of relationship to their function of being magnets. And I was right. Now, another thing is that there's only one element that's anti-ferromagnetic. So therefore, that is the perfect choice for some different research that I completed last year. And I'm trying to publish that in a journal right now. And during 2020, I'm going to be announcing a new paper being published on the anti-ferromagnetic element. There's only one, and its shape is different than any other nucleus, which I've made a mock-up of. All right, so next I had a lecture on a molecule from nuclei. This is about chemistry, molecules. And it's really based on a new concept of electron pairing with protons. And the word pairing needs a definition, which I have not provided yet. Now, the pairing involves 2 space-like flows and a time-like flow. And by using those 3 flows, a spin is produced. 2 spins are produced for each pair of proton-electron. And these compose a flat subuniverse in molecules. So if you have carbon with 6 protons, that would contribute 6 flat subuniverses of the proton-electron pairs in a molecule involving that carbon nucleus. Now, neon was shown in one lecture, and there's a color photograph available on the internet. If you want to compare experiment versus the theory, a good thing to do is to go to the internet and go to a major search engine and to the images section there, and you then search for neon nuclear structure or neon Schrodinger's equation, shape of the nucleus. And while you're at it, you can look for pear-shaped barium. Search for... There's plenty. I did that yesterday. There's so many pictures of the pear-shaped experimental results on radon, radium, and barium. I don't have to violate copyrights. These search engines have already made arrangements with the government so that they don't have to comply with laws like I do. So I don't have to show these color photographs from barium or radon. Other people are showing it to you on their search engines. Now, flat cosmologies in an atom was one lecture, and I would just like to say that quarks are obsolete. Anything in an atom does not have anything to do with quarks. Anything that's flat has no quarks in it. Cosmology has zero relationship to quarks. That is a wrong theory. I'm calling upon administrators at major universities around the world to begin the phase out of quantum chromodynamics. It's a wrong theory, a complete failure. Only self-serving papers have been produced by it. You're wasting the time of students around the world. Please, have mercy. Have compassion for the students. Don't require them to study things that make no sense, that have no jobs, no meaning in the universe. They're just like doing too many push-ups. Give them a break, will you? Now, in one lecture, I talked about the cosmology of eternity, and matter became dark matter, and back to matter again. That's the short story of what happened during eternity, right in the middle of eternity, like today. December 16th, 2019, we're right in the center of eternity. Like the Big Bang also occurred at the middle of eternity, recently. Now, dark energy is electrons that went to the ends of the universe during expansion. Dark matter is the matter with no electrons that was left behind as the electrons became ionized and flew away during a gamma ray burst. Now, replenishment of space is going on because dark energy is replenishing the space that was being consumed by matter here in the galaxies. So in other words, here on Earth, we're consuming space and giving off time in an equal amount. That time goes at the speed of light out to the ends of the universe, where it encounters those electrons, dark energy. The electrons consume time and excrete space back down upon us, and that is replenishing the space that was consumed by matter. So, my comments on the ab initio lecture is just that I'm replacing the old conservation of energy in Schrödinger's equation by using conservation of continuum, the mirror in the proton, the balance of space-time, that the amount of time coming out of Earth is equal to the amount of space going into Earth for gravity. And the mirror in the proton has a attraction between the 3D gravity and the 2D electromagnetism. So that's why electromagnetism is so strong compared to gravity. It's only in 2 dimensions in a flat subuniverse where a proton is either interacting directly with one electron or that pair is indirectly interacting with other pairs through exclusion principles like the Pauli exclusion principle. And then I just wanted to also comment on the English language here, mass versus matter. M stands for mass, not matter. Please stop mixing the two together. If you're going to pretend that mass is equal to energy, don't pretend that matter is equal to energy too. Just because they start with the letter M. I've heard a lot of scientists mixing the two up as if matter is just mass. No, matter is not just temperature of matter. It's not just the gravity of matter or the inertia or the volume or the electrical charge. Matter is complicated. It's everything. Mass is an area of matter. All right, so I'm almost coming to the end of my list here. You notice in the new periodic table, it's divided left and right. There's a big gap down the middle of my new table. Technetium and iron. In fact, I can just show it to you now. Here it comes. There, it's split down the middle. On the left side of the split, technetium and promethium. You see that those are cube 4 elements. Above it is manganese, cube 2. On the right, they're all cube 3 elements. Iron, ruthenium, and samarium on the right split there. That's good. We got rid of the lanthanide series and actinide split there. So you're able to see nuclear structure lining up between cerium and zirconium. All right, so I see we have 3 minutes left still. And winding up here, let's see. Let me go down here. Now, the thing is that future electricity is important, the generator here. So there's the final goal, the generator. That's why I'm doing all this work, laying the foundation of science as low as I can. These are the lowest ideas in the universe. Conservation of continuum, the mirror in the proton. Negative infinity is where the proton has its core. And I'm trying to figure out how to make the generator, and I don't have an answer yet, and I'm just using my time to make a foundation for future design of the generator. Or we could just put a tokamak on the backside of the moon and make the containment out of fuel, like hydrogen frozen at 10 degrees Kelvin. But I don't think that's really practical either. The future physics, I talked about an iron atom and the non-crossing law that unifies many Pauli lens phenomena. Now, I'm going to be switching these pictures rudely for you here. Oh, here it comes. All right, so the practical purposes of this is many. There are many practical purposes for these ideas. Charge distribution in chemistry can now be put together geometrically from the way the nucleus has charge distribution. Let's look at some quick pictures here of charge distributions. You could go to my website on Thingiverse and look at the charge distributions that I've provided for you there. All right, so these models using Blender software were put together while allocating the protons. Now, Also, you can show them without knowing which ones are protons and which ones are neutrons, because that determines the shape and the silhouette in these models. Just like on the periodic table, I'm showing silhouettes without identifying protons and neutrons usually. However, I also have white protons shown for these elements and blue neutrons. So you can get them and rotate them around and things. There's a radon model with white proton charge distribution. And then electrons will be paired up with each of these white protons. Oganesson, polonium, with its nuclear vulnerability, it's so radioactive and everything. And that's explained right in the text on this Thingiverse website. And then the integer geometries, I give 3 sets of modules to make every element in the periodic table. There's set number 2 on the right. There's a cube 4 and a pyramid 5 there, and a dilator 4-3. Promethium, the riddle is solved. And I hope you go there and rotate these in the 3D viewer, use a virtual reality headset with 3D illusion, or just use a 2D display like I use for the 3D illusions. There you see lithium, very important. It's rare. Lithium is rare because iron is common. And you see the white protons form a line of protons, and the neutrons also form a line. I've compared carbon-13 and carbon-12, and I've explained how copper is non-ferrous because of that short circuit there in the ring, whereas nickel, with one less proton, white, in the middle, does not have a connection from the ring to the axis. And on the right, you see the cube 2 from the nucleus of oxygen. The cube has 2 layers of 4 nucleons. So I'm about ready to wind up the half hour for today. I'm going to relax for a while, go to 2 days a week, Monday and Friday, and I'll be in a quiet workshop, just moving little protons and neutrons around for your entertainment. Now, chemical facts also include the octet rule. Like I was saying, 8 is 6 plus 2. A cube has 6 faces, and the cube has 2 protons in it. I'm providing simple answers to old questions. This is the end of the semester, fall 2019. Bye. Hello, it's Alan Folsby here in my front yard. This is where I discovered the shape of the iron nucleus.